Hey guys, I just want to pop in here and go over two review questions. One is going to be the question that was in the sample questions. I just want to work through it. For most of you, I have responded to you and told you what you got right, what you got wrong, but in case you want to see it worked out, also as I work through it, I'm going to give you some tips on how you can enter this and show your work in a more condensed fashion. So you might want to listen to that and also look for how you might prepare a sample problem to help you on your test, okay? So let me flip my camera here. All right, so the question that we had, this is already balanced. One of the things that you had to do was balance this equation. So I have already balanced that. And let's move on with the information that we were given, which is we had 80 grams of iron and 105 grams of sulfur. And the first question that we were asked was, I have our list of questions here. So one was balance the equation. The second one was find the limiting reactant. So let's do that. So to find the limiting reactant, we are going to, so this would be A. So we are going to take 80 grams of iron, and we're going to find out how many moles that is. So we're going to say that 1 mole of Fe has a mass of 55.847 grams. And then we're going to grab our calculator and do that calculation. And I already have these done, so I'm going to move a little bit through this. So that's 1.43 moles of Fe. The second part of this question, of this part, would be to take the 105. So 105 grams of sulfur, 1 mole of sulfur, has a mass of 32.066 grams. And so it's 105 divided by this, so this is 3.27 moles of sulfur. So these are our available ratios, and we need to compare those to the ratios in the balanced equation. So the next thing that I would write would be my balanced equation ratio is 2 to 3. My available ratio is 1.43 to 3.27. And one of the ways that we have been working this is the smaller number. So we'll divide and divide. And this now gives us a ratio of 1 to 2.3. So now we need to compare these two ratios. So this is really, if we want to reduce this, this is really 1 to 1.5, right? So 1 to 1.5. So 1 to 2.3. 1 to 1.5, 1 to 2.3. So that means I'm going to have sulfur in excess, and iron is my limiting reactant. So limiting reactant is iron. This means that my information for iron is going to drive all of my stoichiometry. So what do you need to write down to type into the box? Well, the first thing you can type is actually this answer. The limiting reactant is Fe. You can type that answer. Then you could show me how you got there by typing 80 divided by 55.847. I will allow you to leave off all the units. This divided by this, and then this. 105 divided by 32.066 to get me this, right? So you can shorten up the amount of typing you need to do when you are working through these. You will need to put these two ratios in your work. That's how I'm going to see what you have done. So record your answer. Of course, you can't circle it up. Record your answer and then show some work. So this would be, so you would type the letter A, there's the answer, and then give me some supporting work typed in behind it. Okay? Now let's look at the second question here. The second question said, how many grams of the iron 3 sulfide can be produced? So here this is B. So here we're going to take our limiting reactant, 1.43 moles Fe, and we are just going to we're going to use our stoichiometry path to go from here over to the right answer. So our mole ratios from the balanced equation, remember we're always pulling these from the balanced equation, not that unbalanced equation that was provided for us. Oh, I'm sorry, I wrote a 3. We're going over here. It should be a 1 mole Fe2S3. And then we're going to now do the mole ratio here. So 1 mole on the bottom. And then the molar mass of this is 207.892 grams equals. All right, so what can you type for this? So let's just do this. Let's go ahead and get the answer. So the answer here is 1.43 divided by 2 times this. So the answer is, when we adjust for sig figs, is 149 grams of Fe2S3. So you could type your answer first and then come in behind it to show your work. So your work, type your work to be this: 1.43 divided by 2 times 207.892. That's the work that you did. That's the math that you did, okay? That cleans that up a little bit. It's correct on your paper, right? It's correct on your paper, but you're showing me the work that you did that got you to here. Hopefully that will help you be able to more speedily prepare your answers. Okay, so that would be B. So this is what you could type, all right? Let's look at the next one, which is, and this one gave a few people some problems. So one, I'm just going to quickly put my balanced equation back up here. 2, 3 sulfur, and then Fe2S3. You would not need to write that again. That would be there for you. So the next question is, how many grams of excess do we have? All right. So there are more than one. There's more than one way to work this problem, but we have to start with the limiting reactant. If we start with the limiting reactant, we can discover how much sulfur was used and then subtract to find out how much sulfur we have left. So the balanced equation says this is 2 moles of Fe to 3 moles of sulfur. And then the molar mass of sulfur is 32.0 0.066 grams. All right? So this first number I'm going to get here, which is 68.8 grams of sulfur, that is not the answer to the question. That's how much was used. Okay? Another way to do this would be to go here and find out how many moles, and then subtract those moles from the available moles that we discovered earlier, and then convert that. That's exactly the same thing. It's just coming at it a little differently. So here we had 105 grams available at the beginning. If you remember, that was our beginning information, minus 68.8 grams. So that tells us that we have 36.2 grams of sulfur left over. All right, so again, your question might be, how will I show this in that answer box? All right, so one thing that you could do is go ahead. So this was letter D. So you would write 36.8 grams sulfur. That's the answer left over. And then you might just give me a sketch of the math. 1.43 times 3, divided by 2 times 32.066. And then you would write that gives you 68.8 grams. And then you're going to take then the next part is to take 105 minus 68.8 to get you 36.2. That's a way to shorten, right? So this would be what you typed, right? Because that's what you're literally putting into your calculator. This is the work on your paper in case you have to prove your work later. So that's the work on your paper. This is the work that you're showing me in the box. You are welcome and encouraged. If you're a fast typer, you're encouraged to type all of this up here. But if that's going to be a problem for you or a struggle for you time-wise, give the answer and then give the math that supports the answer. The next part here was to do percent yield. So we were told in this problem that 99 grams was actually collected, but we discovered through our stoichiometry that the theoretical yield was 149 grams. So we're just going to do 99 divided by 149 times 100, and that gets us to 66.4% yield. That is not a very efficient, so if we're evaluating that, not very efficient or productive, not very efficient or productive. The last question here, a few people ran out of time on this question. This says if we have 285 grams of Fe2S3, how much iron was required? So guys, this is just an additional stoichiometry problem where we go back to the balanced equation, but this now is our starter. So this is 285 grams Fe2S3. 1 mole has a mass of 207.892. The balanced equation ratio is 1 mole to 2 moles of iron, and iron is 1 mole to 55.847 grams. So when we do that math, the answer is 153.1 grams of iron. Again, you could put in the math, you could write out, so that would be the answer. And for your work, you could say 285 times 207.892 times 2 times 55.847. I'm going to do one more example problem for you in another video because I'm out of time on this one.